All right, welcome to Hour of Code for the Code Together Discord. Today's session is on unit testing, and what we have in front of us right now is today's agenda. So let's start talking a little bit about testing in programming and what that is and why we do it. So as a code base grows and you write more and more code, we tend to get into this problem that code is not like code kind of tends to become kind of like a spider web, like it entangles other pieces as you go. So while you might have something that like is perfectly fine and lovely, but then a few months down the line you like, oh, we had a bug here, or like, oh, we needed this new feature, and you make some changes to your original code, and now suddenly maybe accidentally you broke something, and unless you actually start the program and happen to click the exact correct buttons, you won't notice. So that's where testing comes in, and there's like a whole bunch of different types of tests. In professional programming, there's even a few whole jobs specifically for testing. There's a software tester, and you have QA engineers, and all this kinds of jazz. But we're going to talk today primarily about a special kind of testing called unit testing, which is normally performed by the programmers themselves. So this is not something you would hand over to a tester. This is something the developers are expected to do by yourself. And this is unit tests. There's also something called end-to-end testing, which sometimes developers do, but sometimes you have QA engineers do it. And the difference here is that unit test tests one very specific component, a unit, a part of your code. It's very in C#. That's very often a class. So you'll make a bunch of tests that test one class. While an end-to-end test is much broader. Like, for example, let's say you've made a web API. An end-to-end test there might be, go to the products listing table and make sure you receive the products that we know are in the fake database we just set up before we started this test. So they will test, the HTTP pipeline, the middleware, the authorization. They will test everything. Like, given that my request is valid, make sure the response is valid, sort of thing. And if you want really good test coverage, if you want to be 100% sure that your application works as expected, you should have both. You should have unit tests to make development easier and faster, and you should have end-to-end tests to make sure that the whole product actually works as expected. So what is a unit? Well, in C#, a unit is often a class or a method. So what I have, for example, the code we have in front of us right now, I'll make it slightly larger. This is a very, very simple calculator class. We have an add method, we have a subtract method, we have a divide method. And, obviously these are incredibly simple, and it's not very likely that you would need to go in here and fix a bug in the future. But still, we're going to write some tests for this class, just to show you how it's done. So I'm just going to move the agenda over to my other screen so I can be reminded of what it is. And let's get started. So unit tests, you write them in their own special project. So the first thing we're going to do is we're going to go up to our solution here and click Add New Project. And there are a few different test projects. If we just type test up here, for example, we'll see there's NUnit, unit test project, and XUnit. I like XUnit the best. That's the one I'm used to using, and honestly, the one I recommend. If you ask me, it has the best defaults and the best setups and everything. Now, naming your test project, it's a good idea to name it exactly as you named the project you will be testing. So I'm going to name mine exactly like that, but then we add dot tests. So it's if I was testing the async stuff, it would be called hour of code.async and task.tests, etc. So we'll make this, and we'll make it with the same framework as the original project. There we go. Now, this is your very basic unit test. It's just a class. It's just a class that has a method, and the method has some kind of attribute. In XUnit, that attribute is called fact. This means that this is a test. This is one single test, and that has to be true. Otherwise, that's why it's called a fact. It's like it's stating that this test is a fact about my code. So we're going to do a few things. First, we're going to add a project reference to the thing we're going to test. So all the code we're going to test today is in this project, so we need to add a reference to this project. And how I did that was right-click dependencies and click Add Project Reference. Now I can access that code from here. So we will start writing a very, very simple test. Now, a very, very classic architecture for tests is arrange, act, assert. So we'll write them down. Arrange, act, assert. That means arrange here is where you do your setup. Act is where you call your actual unit you are testing. And assert is where you then verify the result of the operation. So for example, in my arrange, I could do like var input or like var a equals, we're going to test the add method here maybe, so I'll do 5. I'll say var b equals 3. I'll do var expected equals 8, right? Because 5 plus 3 is 8. Now my act then will be calculator dot add a and b, and I'll do var actual. So some very common terms is actual and subject. It's very common to see that thing you're testing. In this case, right, it's a static class, so I don't need to instantiate it. But if I did need to instantiate it, I would probably have called it either subject or SUT. SUT stands for subject under test or service under test. And it's the thing you are testing. And actual is the actual value we got by calling this, and now we're finally going to assert it. And we do that by the assert class. XUnit provides this for us. So we can do assert equal expected and actual. So now we should give this test a better name. So we're going to call this add should add 2 numbers together. Yeah, that's a good name. I think that's what it should do. So we have slightly different naming rules when it comes to tests and normal methods, because you'll never need to call this method, so it doesn't need to be short and concise and lovely and readable. It's much better that it is abundantly verbose and clear about what it is testing. And I'm going to show you that because down here I have something called the test explorer. We'll just rename the unit test case here as well, because this will be what we're testing. So this will be calculator tests is a good name. Normally it's like the class you're testing and then followed by the word tests. So now if we build this solution, because this is code, right? This is code just like any other project. So we need to build it for the test explorer to be able to access it. So if I can break this out and make this a lot bigger. And we can see here that I found a test. My test is called add should add 2 numbers together under calculator test. So we can right click and do run. And it's green. The green check mark here means the test passed. That means that what that actually means is that the unit test code did not throw an exception. I'm just going to put that down here. No, it doesn't want me to put it down here. it's supposed to be able to. Oh, right. I need to drag this. Sorry, I'm dragging the wrong thing here. Or apparently it just doesn't want to go where I want it to go. That's okay. This is not what we wanted to happen. Okay, fine. We'll add this here, and we'll add this back here as well. I don't know why they're being so stingy. Normally it's perfectly fine to stick the Test Explorer down here. Right. So, and what this assert method will do, this equals method, it will make sure that the two things you passed in are the same, like that they equal each other. Otherwise, it will throw an exception, and if your test ever throws an exception, that will count as a failure. So, for example, just so we can see what a failed test would look like, right? Let's change the expected value here to 10. So we're saying that we expect adding 5 and 3 together to return 10. If we now then run our tests, we get a failure. And it's saying here that assert equal failure, expected 10, but actual was 8, right? This message is generated by the assert function itself. I don't particularly enjoy working with xunit.assert. So I'm going to show you some alternatives later for what we can use instead. I think the asserter is one of the weaker points about this, but luckily the asserter is literally just a class that throws exceptions when things don't really add up. So we can replace that with something else that does the same thing. Okay. So let's if you remember the calculator, we had a few more methods. So let's test them as well, and let's change the assertion library. So what we're going to do is I'm going to go here, and I'm going to click here dependencies again, and I'm going to go manage NuGet packages, because I am now going to install some other packages that I really use like for testing. So we're going to install MOQ, mock. That's a mocking framework for tests. It is really good. I'm not going to use that directly now, but we will use it for the later tests we're going to write. And we are going to add fluent assertions. This one, not fluent assert, fluent assertions. This one with 93.7 million downloads. It's a very, very, very popular assertion framework, and it's very nice and lovely to work with. So we're going to install those. We're going to go back to our test. And we're going to change this out for actual should, and we'll have to import fluent assertions, should be expected. Now remember, we're still saying 5 plus 3 should be 10, so we can run this again, and we'll get a different error message. Now it's saying expected actual to be 10, but found 8. So I think this is more readable, and as this gets more and more complicated and you're testing other things, this message kind of stays pretty readable, which I really appreciate with Fluent. It's less like assert equal failure, expected 10, actual 8. No, it said expected actual to be 10, but found 8. It's more fluent as in the name. So let's change things up so that it actually works again by changing this to be 8. And we'll run it to make sure that it worked. Perfect, it worked. Right. So then, how do we make a new test? Well, we just make a new method. So we'll call public void subtract should remove B from A. And we will do var actual. So I can since these are so simple, I can actually inline them. So we can do var actual equals calculator dot subtract, and we'll say 10 minus 2. And then we're going to do actual should be 8. So you can make these very short when they're so simple. But this is not a test yet, as you can see here. Like, it just doesn't show up. That's because we didn't add the fact. So we'll add the fact, and suddenly it shows up. So we can now run it. Yeah, and that worked too. Great. However, what if we had a bug? What if we had some weird bug where this only worked for certain numbers? Like maybe we should have some more numbers. We can do that. So we can replace fact with theory. Theory is sort of like fact, but it will try to insert things via the parameter. So we'll have int a, int b, int expected. And we will replace 10 with a, we'll replace 2 with b, and we will replace this with expected. And now we just need to add some data. So we'll do, there's a few different attributes for adding data. So there's one called inline data, where you can do things like, 5 minus 3 should be 2. And we can add another one that says 10 minus 5 should be 5. And we'll add one more for good measure, where we'll test some negative numbers. We'll say minus 5 minus 5 should be 0. And then, now you'll see that we have 3 of these. This test just became 3 different ones, because it figured out that, hey, you actually have 3 different tests here. You have 3 test cases. So we can run all of them. And hey, guess what? They all worked. Perfect. Right? So suddenly, this is already a better test than this one, because 1, it's more readable, and 2, we have more data. Like, there's more test cases in here. Let's test one more, because the divide one is a little bit more interesting. You'll see we actually have a special case here where we're throwing an exception. And you don't want to, it's very easy that you end up in a trap where you only test the happy flow. But I think it's pretty important to test that your class behaves correct under, your unit rather, behaves correct under errors too. So let's write a test for that. So we'll say public void divide should throw an exception if division by 0. So this will be a fact, because we just need to, we don't need to divide by 0 10 times. It's gonna, like, if it works once, it's gonna work 1. So we'll do, and this one is very different depending on what assertion library you're using. And it's, if when in doubt, it's probably a good idea to just Google it up. So I'm going to say that, in fact, let's do that, right? Because I suddenly forgot how to do that with fluent asserts. So we'll do fluent assert exception. Look, I apparently have Googled this before. So you do subject.invoking, right? But we don't really have a subject. So maybe we'll set up an action instead. I think that would be better. So we will set up an action. So we'll say action act. Oh, we need, yeah, so there we go. Equals calculator.divide, and we'll say divide 5 by 0. Then we can say act should throw, and we can give it a type. So we can say divide by 0 exception. And let's see, was there anything else? Nope, that's fine. We don't need to actually, I think should will actually invoke it by itself. So if we then, we now have a new test here, we can actually run all of the tests. Hey, looks like it worked. So it's saying that, yep, this actually threw. However, we've only tested that one. We should probably test that it works fine. You know what, we'll copy this one instead. We should probably divide should divide A by B. So we'll say, what is 10 divided by 2? That's 5. We'll do 100 divided by 5. That's 20. And we'll do, I don't know, This is integer division, by the way, so I'm going to do whole numbers. I'll do 8 divided by 4 is 2. So then we'll change this to be divide, and, otherwise we're all fine. So let's just run all the tests again. Look at that. They're all passing. Perfect. Just to demonstrate how it would look if this one was to fail, let's make this fail. So I'll go in here and I will just I'll just comment this line out, right? Maybe that was I was like, oh, why are we throwing an exception here? That's ridiculous. In fact, I mean, actually, I think if I do divide by 0, if b is 0 here, I'll actually do that anyways. We'll just say return, 5. We'll hard code it to return 5 if you try to divide by 0. So then if we run all the tests, hey, expected a system divide by 0 exception to be thrown, but no exception was thrown. Oh, drats. Can we fool this, maybe? Can we just do throw new exception? Nah. Maybe we'll just try with a different type of exception, Nope. Expected a system divide by 0 exception to be thrown, but found a system exception instead. And it's even telling you the message and stuff. So nice. Very easy to track it down. But let's restore our code so we have some nice tests here. Make sure they all run. Yep. And also, if you want to run all the tests, you can just click up here. And then we'll move on to the next topic, which will be a slightly more difficult unit test. Now, because this class is extraordinarily easy to test. It's a static class. You don't even need to construct it. The methods are static. They don't use any, they have no state or anything. Like, there's nothing for you to set up. There's nothing to verify except the response type. So I have a little bit more of a complicated thing to test, and I'm going to show it to you. It's this shopping cart service. So if we look quickly at what it does, right? We can make a new one. This is the constructor. We can make a new one, and it requires an iProduct repository. Okay. We can add an item to the cart by adding a product ID and a quantity. We can update quantity by passing in the product ID and the quantity. There's a private method to do that with a product reference instead of an ID reference as well. And then finally, there's remove product, which will just remove the entire thing from your shopping cart. And then finally, we have public IEnumerable and a tuple. So we can get a list of, like, we can combine, you can just get all the things that are in there. And for each product, it will tell you how many there were. So we're going to test this. But we have a dependency. So that's going to be interesting, right? We're going to have to solve that. So let's go back to our Solution Explorer and create a new class for our test. So this will be our shopping cart service tests. We'll go ahead and make this public. And we will make a constructor. So this is different for each test framework, but like I said, I love using XUnit. It's my favorite one. And the constructor here will actually create how XUnit will do internally when it's running tests. I'll make a test here, public void test. And I'll mark this as a fact, which means I need to import XUnit. So when it's trying to run this test, it will first run the constructor, and then it will call the test. And if I then have another test, I'll make a test 2. It will not reuse the same instance. It will use 2 different instances. So that means this code here, anything you put in the parameterless constructor can be sort of thought of as run before each test. And what that means is that it's a very good place to set up things that you always need to set up for every test. In this case, for example, since we're going to close down calculator and calculator test, we're going to close down everything else except shopping cart service. This is not a static class, and none of these are static. So we're gonna need to have a subject, a service under test, in order to test this. We're gonna probably set that up here. So we can do something like subject equals new shopping cart service. But it's complaining. Oh, that's right. We didn't add a product repository. So we need to make one of those. We'll set this up though. We'll generate this as a read-only field. So we need to create that. So I'll just do like var, or I'll do like product repository equals what, right? Because I can't create a new product repository. Because because my code currently doesn't have any real product repository. There's only the interface. But even if there was a real one, if I created it here, that means I would actually be running the real code for shopping cart service, but also the real code for product repository. And that would be bad. Why would that be bad? Well, because I wouldn't have a pure unit test. I would actually be testing 2 units. I would be testing both my service under test, but I would also be testing the dependency. And that means if I introduce a bug in the dependency, these tests will fail. Now, obviously, this is that would maybe you say, but that's a good thing, right? That means you catch more errors. Well, no. Obviously, you want to have your own tests for the repository because you want to know what broke. And you don't want to have one test that tests your entire program that said, hey, your program broke. You want to know exactly what broke. That's another thing with integration tests, right? They will tell you that something is wrong, but they won't be able to tell you exactly what. A good unit test will basically be able to pinpoint the line where it broke. So what do we do? Well, the traditional solution here is to create what's called a mock. Now, there are very powerful mocking libraries like the one we installed earlier, MOQ. But first before I do that, because that might be a little bit daunting, a little bit jarring, it's a lot of functional code going on there with lambdas and stuff. So before we show that, I'm first going to show you how you can create your own manual mock. So what we will do is we will create this field, and I will say that this is an iProduct repository so that it compiles. And then I will say new mock product repository, and I will pass that in here. And that means, of course, I need to create this. So now you could create this in a new file, and we'll do that here, right? And I'll move it to .mocks. So I'll move my file here. Boom. See, we're now over here. And this is now an internal class mock product repository, iProduct repository, and we'll make it implement that. And this is perfectly fine. Right now I have a folder for my mocks, and I could now, maybe I have another service that also relies on this. Now I can just use that. We'll just clear that up a little bit as well. But we do have a problem here though. We need to implement this somehow, right? So we need to pass in an item, and we need to get a product back. So, well, we'll just we'll just do something simple. We'll just do return new product, and we'll just pass in the same ID we got, and we'll say mocked product, and we'll say for price, I don't know, 2 cents, right? This is my 2 cents. The M is for decimal, by the way. Don't ask me why it's an M, but it is. I guess D is for double, so. There we go. That's a pretty simple mock. This one will always return the same item, but that's fine. So we'll go back to our test, and then we'll see what we need to do. So what do we need to test here? Well, we need to test add item to cart. We should test that. We should verify that if I add an item to the cart, and then I try to get the entries, I should get the thing back. Yeah. Let's do that. So we'll change the test name to be add item to cart should add an item to the cart. Yep, that's good enough. So let's see. Let's go back to arrange act assert, right? Do we need any arrange? We're not sure yet. Let's be a little bit greedy. Let's jump directly to the act. So we're gonna do subject dot add item to cart. Okay, we're gonna say product ID 1, and quantity 1. Okay. Now, so that's the act.
Is subject a naming convention?
Yes. So it's you normally call it either subject or SUT.
Okay.
SUT, or subject under test, or service under test. I come from subject. That's what I'm used to. If you want to call it SUT or service under test, that's fine by me.
Yeah.
But yes, it's traditional that we always have it called something similar. And then finally we'll do asserts. So we need to, what do we need to assert here? Well, here's kind of the problem. This is a void method, right? It doesn't actually give anything back. So voids are really hard to properly test, because normally you'd want to test the return value, but this doesn't return anything. It's just updating internal state. And we can't actually access this, right? It's just updating this thing, but we can't access that because it's private. That's a shame. Well, I mean, we do have this thing, right? We do have a public accessor. I guess we'll have to have a sort of imperfect test, in that we can't test add item to cart without also testing get all entries. But that's still a better test than having no tests, even though we're technically testing two methods. Well, so this test is now assuming sort of that the get all things work. So we'll say var get all items in cart equals subject dot get all entries, and we will since that's a we'll do to list it, and the reason for that is because it's IEnumerable. So if you just get the enumerable, it's deferred execution. So we want to call it so we know that we have we want to do it right now. Now we have all the items as a list. So now we're gonna assert it. I guess we could put this under act. And then we assert. What do we assert? Well, I'll probably say that all items in cart should. Oh, there we go. Should. Well, it should not be empty. That's for sure, right? We know that. That's a good start. Well, I mean, we know there's going to be at least one item, so we should do 0.should. And what is that? Right, that's the tuple we have, right? So we can actually do dot product to get the product number there. We can do product dot ID should be, and then here we go. Now this should be a variable, right? So now we can actually, so we have var product ID equals 1. Now we can stick that in here. So product ID, and we can say should be product ID. Cool. But let's also verify the quantity. So that we should just do that. Should be quantity. So var quantity equals 2. We'll just change that to a 2 for now. There we go. So now we actually have 3 things we're testing. And that's okay. Like it's okay to have, we're only testing, well, we're testing these 2 methods, but we have 3 asserts. Some people are very anal about having only 1 assert per test. So that means they might actually write 3 test cases that does the exact same thing and then test 3 different things. I think that's too anal, because the benefit of doing that is that, well, I mean, you can then in the test name here specify exactly what it is you're also asserting. But I think that like any test failure means you're going to go read the message anyways. That means you're going to fire it up, run the test, and check the failing message. So since these will generate the proper message, there's also one more case. Like, so if this one would cause a failure, these would not be run. Meaning, technically, maybe I have 3 bugs here, but I wouldn't know until this one is fixed. I think that is a trade-off I'm willing to take, in that I will run my tests manually a lot, and I will also, when I'm fixing a bug where, for example, my build pipeline tells me that a test failed, I will run the code, make sure I can duplicate the failure, fix it. I will then run the tests to make sure I fixed it, and that means I would then hit this point, and if this would also fail, I would have to fix that too. So there's 2 different schools to it. I prefer this. Okay, so let's test this test we just wrote, right? So let's go to Test Explorer. We can minimize the calculator tests. We're not really interested in them right now. And here we go. Add items cart should add items. Let's run it. Whew, look at that, it worked. Perfect. Maybe we should test some more things. Like, for example, maybe there should only be one item, right? There should only be one entry. So it should not be empty, but it should also be all items in cart should have count 1. Yeah, that's even better. Let's run that again to make sure that's still true. Oh yeah, there we go. Perfect. What else can we test in here? Update quantity, right? We can add an item, and then we want to be able to change the quantity. Yeah, that makes sense. So, in that case, we want to basically change this test to be that. So we'll say update item, update quantity should set quantity if, we'll do one of this, if product was added to cart. Because with this one, we have a little bit of intricacy. What if you call should set quantity when there was no item? So let's already make that one. So should fail if product wasn't added to cart. So let's add the one that works first. So we're gonna do pretty similar stuff. We're gonna do subject dot update quantity, right? And we're gonna we're definitely gonna run product. So product ID equals 1. We'll say product ID, and we'll set the quantity to 100. And then we're gonna have to do something very similar to this, where we get it out. And we'll want to expect that to be, so var new quantity equals 100. Right. So this won't work just like this, right? Because we've said that we've actually, I mean, we could have looked at the code and say that, oh look, if product is null, by the way, if product is null, if it doesn't get anything back, it will throw an error. We should test for that. And then also in this internal method, since I wrote this, I happen to know that if, for example, if you specify the quantity to be 0 or below, it will actually remove the product from your cart. And otherwise it will update the cart. And finally, if it wasn't in the cart, it will throw this exception. So we need to add it first. So yeah, I suppose once again we have a little bit of an impure test because we need to add an item first. So we need to do product ID, and we'll do 1. So we'll add an item, we'll then update the quantity, we'll then get them all out, and we'll make sure that they are what we expect. Let's run all the tests. By the way, an empty test like this, they will always pass. Because, like I said, they only fail if you throw an exception. So that test actually succeeded. First try. That's pretty good. Normally, when I develop tests, it's very usual for them to be failing for a few minutes before I manage to set it up everything correctly. And we'll probably have some of that going on later. So now let's basically repeat this test, but for the fail, right? So we'll just not add an item. Yeah, let's just not add an item, right? And then when we do this, we are not going to expect this to succeed. We're actually going to expect this to fail. So we'll do the same thing we did before. We'll create an action. So action act equals subject dot update quantity product ID 100. We're not going to need to refer to any of these again, so that's fine. We'll just pass it in there instead. And then we can say act should throw invalid operation exception. See, that was quick and dirty. Let's test that. Hey, it works. Perfect. Right. So there's a few more things we should test, really, if we were to be really good developers here, right? We would test a few more things. We would, for example, we didn't test this case yet. Because we would need to set up a different mock, or we would need to change our mock for this. And I will go through how we do that with MOQ very soon. And we didn't check this either. Oh, wow, yeah. But you know what? Let's change our mock here. Let's, instead of using our own mock, let's remove that. We will delete that, and I will use the mocking library that I talked about, MOQ. So when using MOQ, instead of creating your mocks directly, you just instantiate a mock over the interface that you're mocking. And then you just you can new them up either like this or the more classic mock. Hang on. It was actually trying to autocomplete that for me, but I failed that. Nice. There we go. This is what you need. And now you can't just pass it in here because it's of the wrong type. It has an object property though. You'll just do .object because that is the interface that has been mocked when this is doing. So we'll need to change some stuff around because now I'm pretty sure if we run all our tests now, let's go back to the Text Explorer, sorry. Run all our tests, they should all fail, I think. Yeah, they're all failing. They're failing because we know that the subject internally uses the repository to get an item out, but it's not getting anything. So here what I'll do is I'll say var product equals new product. I'll say, I'll put that here. So I can use product ID. I'll say mocked product, and I'll say, $100. Now, you see now what we can do, because now I can do product repository, right? Because here comes the magic. Because this line will get run before every test, I can do local setup. That means like my test is now self-contained. I don't rely on code somewhere else. In this case, in my mock file, which was in a different file over here, to set up data that I then need to know about. No, in this case, I can specify very clearly in the test what's going on. So I'll do that with setup. Setup is awesome. So we'll do setup, and then we'll do, a lot of people do X. I like to do underscores, but it doesn't really matter. I'll do underscores here because that's what I like. So we'll do product repository, and this refers to the product repository itself. So this is the method we're going to call. It's called get by ID. So we'll say get item by ID. So when you ask for an item by product and you pass in product ID, which in this case is 1, right? Dot returns product. So I've basically configured this method on my mock instance. So when this method is called and 1 is passed in, return this product. So if we now run the add test, it works. This has some added benefits because mock keeps track of a lot of things for us. For example, maybe we want to make sure that we actually check the database. Maybe we're saying we don't think that this test has succeeded unless we actually tried to talk to the database, right? So we can then do product repository.verify, and we'll do the same thing here with underscores. And I can do verify get item by ID, product ID, and I can do times once. This means make sure that get item by ID on the mock was called with product ID as an argument exactly 1 time. If you called it 5 times, this will fail. If you called it 0 times, this will fail. If you called it with another argument, this will fail. So this is basically now we're sort of testing the interaction with the repository as well. But this can be useful, for example, so that we don't accidentally introduce a second lookup. In this case, I don't do that. But for example, what if my code was different? Like you saw how update quantity has a private method that actually gets called. I'll show that, show instead of say. That's a good line of thinking. If we look here, right, you'll see that it actually calls update quantity if it found it. Like it checks, hey, when you're trying to add, it will check if it's already added. If it already is added, it will call update quantity. If we didn't do that, or rather, if we didn't do that with the product, if we did that by passing the ID here instead, right, we could do that. We could pass the product.id here. If we did that, we would hit the public method, which actually looks up the product. And that would be, we would hit the database twice. So maybe we should do another version of add item to cart. So we should do add item to cart should add to the quantity if the product is already added. So we're saying if the product is already added to the cart, meaning we call this twice. What if we call this with first 2 and then we call it with 100? So now we're expecting it to be 102. But it should still only be one item. So this kind of makes sense. Now this is interesting though, since we're verifying down here that we only talk to the database once. What I think is going to happen now is, because we're actually talking to the database twice, because we introduced a little bit of a bug there intentionally. So when we run this code, we'll see that the first one passed, but the second one, we said expected invocation of the mock once, but it was 3 times. What the hell? 3 times? That's crazy. Well, yeah, I mean, we added an item twice. Oh, I see. We hit the like, well, it should be twice. I think there is there's exactly 2. Exactly twice. That's what we want, because add item to cart will always look up the item. So that's where the third come from. So if we change this back to be product instead of product ID, we can now run, and we now have 2 passes because it was exactly twice. Perfect. Cool. See, we caught a little bit of a bug there. Nice. It's assigned to but never used. Let's remove that unused variable. Nice tests go in here, man. Update is not working because we're getting a no such product exception. Makes sense. We didn't set this up. So I can take these 2 lines of code and I'll just stick them down here.
So can you just explain why why you need to add a product again?
Right. So remember that.
Time.
Remember in the constructor,
Mm-hmm.
this gets run before every test. So we will reset our mock. And the thing is, like, if I could call the setup stuff here if I wanted to add, if I wanted this product to always be returned, I could set it up here. And if, for example, if you find yourself calling the exact same setup in every single test, maybe it's a good idea to put it in the constructor. And if or maybe if you're doing a lot of the same stuff, or like this, maybe I need to set up like 10 different things, I could put that in its own method and just call that method here. Because I mean, tests are just code. They're just code that is testing your code. They're verifying things about your code. Why I'm doing this locally in each method though is because it's only 2 lines and it gives me control. Meaning, if I, for example, need to change something, I can do that. Like I don't have to like look it up, take it out, and like do the refactoring. Like it's such a little code. I prefer having it separated because once again, one test should be you want them to be fairly self-contained. Something I've seen at my previous job, for example, was that they would stick, instead of we would have much more complicated fake objects like this. The product here that's a real product. It's just that the values are fake. We had one of those that was a much more complicated structure. It contained like fake API responses from an API that returned, like a response that had maybe 700 fields of data or something. And we didn't need all of them, but we needed a large amount of them. And so it was like a 70 or 80 line setup or something to create that object. So what some developers did, they would create JSON files. They would create a JSON file and just add some code to serialize and deserialize that into an object here in the test. The problem with that was that if we then went and changed the structure of that API object, because the API updated their output formats or something, we didn't catch that error until we ran the tests. When we ran the tests, obviously we got a serialization error, and we're like, what the hell? Why do we get JSON serialization error here? Well, because the test was running JSON code. But more importantly, when we made those changes, we would have got a compilation error if they had actually set their data up like this. That's why I say that you should set up your test data as code, because then you get compilation errors if you change the structure. And compilation errors is the best kind of error because they happen very early. So I say don't be afraid of a little bit of reused code. So we'll have to add this in here too. And now we got this error. Right, sure. So now we can run all our tests, and hopefully they will all work. They all work. Good. I suppose we could test the, zero should call remove product. I think that will be the last test we write for today, and then we're going to be done. I should not copy that test. I very often copy a test because like tests tend to do a lot of the same things. So update quantity should remove the entry if quantity is zero or lower. So we'll set up that. We'll say, yeah. I mean, we'll have to add it. We'll add 100 of them, and then we say the new quantity should be 0. So we'll just remove new quantity there. And we should in fact have an empty cart here. So it should be empty. That's what we're going to say. All right, we're going to add the item. We're going to update the quantity to 0, which should effectively remove it. And then when we get all our entries, it should be empty. Yeah, that sounds good to me. Let's run that test and see if it works. Hey, it worked. So with all these tests, now, for example, I could go in here and create new features or, adapt things. And I could be confident, as long as my tests work, I can be confident in that I have not, I haven't broken existing functionality. There's even a branch of development called test-driven development, where the idea is that before you change your code, you write the test. So you would go in here and you would create a new test that would do the thing you're going to do, right? It would verify the thing you're going to code. For example, what if we said that, like, if you buy 100 or more of something, we should also add a free gift. Like if you buy a certain amount of items, like if your cart ever goes above 100 items, you should get a new free item added to the bag. Right? We could set up a test for that before we even start coding. It would be a bit that's actually it's a fairly bad example, especially since we're adding 100 of things, a lot here. So like we would have to go and probably fix a lot of other tests as they will start failing. But you know what? Let's actually do that. Let's add exactly that case. So we're going to say that if you buy a total of over 100 items, you get a free something. So I'll just take one of the add tests. I'll stick it down here. And I'll just say add item to cart should. Actually, we'll just do like that. So if cart should contain free promo item when cart quantity is above 100. Yeah, so we'll have to make sure that it's above 100, right? So we'll add 101 of something. We'll add 101 of this product 1 mock product. We'll buy 100 of one of those. So then when we get all entries, we should expect it to have 2 entries. So now we get a little bit of problem, all right? Because we need we should also all items in cart 1 product. This should be this should be the free product. So we need a way to identify the free product. Yeah, but we can do that. We can do that. We can fix that. So, for example, I think the repository should have an item called get promo item. So we'll do setup and do get promo product. And it'll say, hey, there is no such method. Well, I mean, I'll generate one. I'll go here, I'll say product, get promo product. Yeah, there's only one of them. It's fine. It should return it'll have the -1 as its ID. It will be promo product. And it will have 0 as price. You can't buy them, they're literally priceless. Right, so we'll just say that when get promo product is called, it will return the promo products. And then product should be, I mean, we can actually verify that it should be exactly this reference. We don't need to do the whole ID thing. We can do that. And we could also verify that, there should only be one of them. You should only get one for free. And yeah, I mean, you still only get to look in the database once, for at least for get item by ID. So there we go. Now we've written a test. But obviously this test is going to fail because, yeah, it only found one thing. So we need to change some stuff. Okay, yeah, well, we'll go in here and we'll say, well, I mean, we'll basically need, whenever we updated the cart, we will also need to, we'll need to raise some kind of event, right? Or in this case, we'll just call the cart has we'll call it we'll on cart update. We'll be a little bit lazy. We'll create, normally this would be like some kind of event class that we would register as a listener to ourselves or something. But but this case we'll just do this. And this obviously needs to be an update quantity as well. So we will just stick it at the end of the before. Well, if we do this, we'll do that. And then in remove product, we also need to put it. So if we, oh, interesting, right? We'll need to change this around. We'll need to move that out of the if statement. And we'll need to add a return. There we go. But we didn't do anything. We hadn't added any code here, right? So the test should still be failing, even though we've added this on cart update. Because what we now need to do is, well, I mean, now we need to look over the total items. So we need to do like var total item count. Should be something like, shopping cart dot values dot sum, and we'll say e for entry, or e dot quantity. We'll just sum up all the quantities, right? Now we also need to make sure do you already have the item, right? If you already have the promo item, you don't get a new one. So if, you know what we'll do? We'll do something, well, when we create this, we have a constructor here. We'll cache the promo product. We can't do that, I just realized, because then we'll need to change things around. But you know what? We can do that. Let's do that. Let's actually do that. This is going to be how it works. So we'll say that promo product equals product repository get promo product. See, because we're gonna write some code, and then things are gonna break, and we're gonna have to fix them. So we'll just store our promo product there, so we don't have to look at the database all the time. So if shopping cart dot contains key, and we'll say promo product dot ID. So if it doesn't, right? So if total item count is above 100, and we don't have the promo product, we will shopping cart add promo product ID new cart entry promo product, and we'll give you one of them. All right, let's run this. It's still gonna fail. Yeah, because we get it. Oh, object reference not set to an instance of object. Oh, we've introduced a null ref. That's because this promo product thing, right? These two lines, they need to be up here. We need to set them up here before, because they need to be done before we pull the object out. And then obviously this is now a problem. Well, that's fine. We'll just we'll promote this. We'll generate a read-only field for it. And then we'll need to change that to be promo product. And that needs to be promo product with an underscore as well. So now we can build this. Yeah, building works. Okay, let's run all the tests. Hey, they're failing. Cool. So expected all items cart quantity to be 102, but found 101. Okay. Expected all items in cart to contain one item, but found two. So we'll check these tests, right? Because now we need to verify why did they fail. Well, in this case, we had two items, right? But we then added 100. So that means we're now qualified for the promo product. So we could fix this in two ways. We could fix this by lowering this and make this 52. I think that's a proper test, because like this test is checking that it should add to the quantity if the product already exists. And down here we say that, hey, you should have the correct cart quantity. You should have the promo product if you have a lot of items. So that's fine. And then it actually, what it say? Wait, oh, it's expecting 102, but found 101. That's because that should be updated, right? That should test exactly that, nothing else. So now we run again. Now they're all tests are passing. So now we can be fairly confident that our change didn't introduce any bugs. Why? Because we did introduce bugs, right? We did introduce bugs, but we fixed them. We went through all the failing tests and fixed them. So now we are fairly sure that this, which is probably not the best way to add a product. Like, for example, in this case, if you now start removing items, you don't actually remove, you wouldn't remove the promo product. So that should probably be fixed. But yeah, but we've already gone a little bit over time. So did we talk about everything? Yeah, we did talk about almost everything. We have two things left, and that's writing testable code and the interface segregation principle. So writing testable code, this code is pretty testable. It's not perfect, right? In that we're doing voids. You should probably try to have return values that make sense. For example, it would kind of make sense if I add an item to the cart, it should probably return the cart entry, right? That would mean, and doing that would let me would like do things like if I update the quantity, I will get to know that, like, hey, this is the total quantity. That's cool. If I just add a new one, it will confirm that it was added in a nice way. Or maybe it should return a bool or a false, like a bool, so it could say true or false if it succeeded or not. I don't know. Update quantity once again should probably return the cart entry when it does, right? Remove product should definitely return true or false, and it should be like try remove, so that it returns true if it actually removed anything and false if it didn't remove anything. Because if you try to remove something and nothing was removed, is that really an error? I mean, in this case, I'm throwing an exception for it, but idempotency, which is like idempotency is a pretty good thing to strive for, and it's basically saying that like if I repeat the same command 5 times in a row, or like if I do the same command, it like a command should be so that in a way that like it can be repeated without causing problems. For example, if it's an add command, it should probably contain some kind of unique request ID so that you don't accidentally replay the same request 5 times and add the same product 5 times. Like that would be handled at a different level than this, but for the remove, it's very common. Like if you look at list remove, like I mean, actually look here. This is dictionary.remove, right? It returns a boolean. They do exactly this. It returns true if the element was successfully found and removed, otherwise false. And that's a good pattern for remove functions. But what makes code testable? Well, if you have dependencies, make sure your dependency is described by an interface, not by something else. Like if it was a concrete class up here, it's much harder to mock. You can still do it with the MOQ, but but it does mean that like you're now tightly coupled with that class. So for higher testability, you really want to use interfaces for your dependencies, and that's also where the name in interface segregation principle comes from. That your unit or your class should be segregated from other classes via an interface. Because in production time, in real time, when this runs, right, there won't be an interface here. Well, it is an interface, but it will be a real class fulfilling it. But because it's an interface, I can now create mocks for it very easily. And I mean, I could even create the manual mock that you saw. I don't have to use complicated tooling that uses reflection in the background. And I think with that, we have finally reached the end. So, any questions before we end this session?
No, not so much a question. It was intriguing, sort of when you start to kind of snowball. Like, so if you update the items but then remove one, you've got a promo sort of item in there. It's got does it have to then remove the promo item because you no longer have 100
Yeah.
items? So like that sort of kind of snowball effect would be really interesting to watch. Obviously, at another time.
Yeah, I mean, and that happens a lot in real life, I would say.
Yeah,
It's like
absolutely.
you
Yeah,
have these complicated clauses, like of 600-700 lines of code maybe or something. Hopefully not, but maybe. And then you're like, oh, a new requirement came in. Well, I'll just hack that in here, and then you run your tests, and you're like, holy shit, 7 tests are failing. And then you fix those
yeah.
7, and now 3 other tests are failing because of your fixes. And the thing is, when that happens, you shouldn't be, oh fuck, I wish we didn't have tests.
I imagine that's like
Because if you
the
didn't have
initial
tests, you
thought, and
wouldn't
then
have noticed that you just introduced 7 new bugs,
yeah, absolutely.
right? That's why, like, there's this classic joke, right, about programmers. It's like there's 99 bugs in the code, 99 bugs in the code. You take one down, you patch it around, and now there's 127 bugs in the code. Like, if you have
Yeah,
good tests, you don't need to worry about bug fixing. You might, I mean, sure, obviously you should still be a little bit careful and try not to do crazy wild changes, but a good suite of tests will catch a lot of errors. So yeah, thank you for today, and we'll see what the next topic is.
thank you.